Nice product placement.
NASCAR driver holding my Coca-Cola just right for the camera. Made by our IT, Eileen Durkin.
I have many talents.
So I think I'm going to go ahead and get started. It's 7:06. We made folks who showed up on time wait long enough. Dr. Bob, if you're out there still fiddling with switches and knobs, we're going to start without you. Dr. Bob is one of the smartest people I know, but prides himself on using a jitterbug flip phone because he refuses to bow to technology. If you're out there, Bobs, hello. Welcome everybody to our February meeting. Our speaker tonight is from the archaeology side, which is nice. We haven't had that in a while. Nicole Cannarozzi. We'll introduce her a little later in the program. But February, this is fossil season for us folks. The rivers are clear. The water's shallow. We got a little bit of rain coming in, so you might want to watch those water levels to be safe. But it's time to call in sick, play hooky from school if you have to. It's time to get out and hunt fossils. This is our season. The next 7 days, I think it's supposed to be near 80 degrees. So there's no excuses not to get out and find some fossils. If you're too busy to fossil hunt, you're just too busy. You need to reevaluate your schedules in your life. So figure that out. Be safe out there. Watch the waters if they do come up with the rain, and of course, social distance, or don't hug no strangers on the river. Good news and bad news to talk about, as most of you might have seen already on the Facebook page and in our newsletter. We have canceled Fossil Fest for this year. Easy decision last year whenever the entire country shut down 12 hours before our show was supposed to start. This year, y'all made it easy for us as well. The vendors, we were at about 33% vendor participation, and we only had about 25% of the volunteers we needed. The fairgrounds was cooperative enough to let us move that date until next year. So it's March 19 and 20, 2022. There's nothing we could really do about it. No reason to argue about whether the virus is here or going to be here. When we don't have volunteers, we need about 125 volunteers to run that show. We were at about 25, 26, including the board. So we were 100 people short of even being able to run it. And when Barbara Fight told me that she only had about 33% of the vendors we normally have, we had to pull the plug and reschedule for next year. So that's the bad news. The good news, we're going to try to do something for you folks, outdoors, safe, make people comfortable who want to come out. We're going to have an outdoor swap meet. Simple, much smaller scale. Again, outdoors, mask will be required on the property. We expect we should be able to get about 30 vendors into the property we're going to hold the swap meet at. It's at 4409 West Alva in Tampa, Florida. It's really a centralized location. It's near the stadium, near Super Bowl Stadium, about a mile from there. So people from St. Pete across the bridges, anywhere in the Tampa area, will be able to get there pretty easy. If you know where the Yankee Stadium is, or I think it's called Steinbrenner Stadium, they call it now, we're just a few blocks from there, near Tampa International Airport. So it'll be easy for folks to get into. $25 per spot. If you want more than one spot, just buy more than one spot. Barbara Fight about that. Her email is in the newsletter if you want to order or come out and sell some stuff. And $2, only $2 for folks to get in and walk around and talk to people and buy some fossils from our vendors. Again, mask will be required. That's in the rental agreement we have for the property. And if you're not comfortable wearing masks, then maybe this won't be for you. Peace River trip, Peace River adventure. I'm looking at that to maybe try to work something out to do something. One of my problems with the Peace River trip is, even though a lot of you folks may not count how many people we have there, we've had upwards of 300 people show up. That's a lot of people for a gathering when we're not supposed to be really having big gatherings. But I will look at it and see maybe we can downsize it a little bit or do something to hold that weekend camping trip. We'll let you know before the next Chronicles come out. We have to before the next Chronicles, or we won't have no time to get you folks signed up. Fossil Chronicles, Dave Hoffman on the cover this month. If you're not a member, you didn't get it. The Fossil Chronicles is looking pretty good these days. Getting lots of participation. Dr. Bob, of course, continues to write articles for us. Steve Vicaria started a column this season, and Rob Carlson is also writing in there as well. So this month we have a pretty cool article about Pat Appledorn, and with the help of Deborah Porter, Pat Appledorn found a high school ring from Atlanta on Fort Island, Pearl Harbor, Honolulu, and 20 or 30 years later, 30 years later, he was able to return it with Debbie Porter's help. Pretty cool. That's a good story. Not really fossils, but he found it. Anytime somebody can dig something up, and he found it right there where we were attacked at Pearl Harbor. The field trips, I wish I could jump this back and forth to different folks, but Fred Hindershot reports that we had a record number of people show up for the day trip to the Peace River. He had 40 plus people show up. That is a big group. The next field trip to the Peace River for a day trip is February 27th. I wish we could do show and tell from what people are finding. So if you folks could, please go to the Facebook page and post what you're finding, so folks see that people who aren't getting out hunting can see that people are finding fossils, and good fossils. And make sure you keep your permits up to date, and make sure you have a permit with you. And yeah, when you find it, tell your friends about the Facebook page, or hash tweet or tag it or whatever you do. I don't know how that works. At the end of our speaker, we're going to give away 2 prizes. I'll remind folks, if you're new, we'll be doing it old school radio call-in. We're just going to call my phone. I'll try to figure out the 12th caller. It's really hard because I get 100 calls at once and it starts rolling over. But anyway, we have a kids pack today with some dinosaurs, some kids fossil or dinosaur face masks, some little writing tablets, and for kids or adults, or the adult who's a kid, we have some nice manatee teeth, one with some root on it, which is not as common. Those are fossilized, not modern. Fossilized manatee teeth. We'll give those away at the end. Meredith Miller, if you're listening out there, I know I still haven't brought out your mastodon replica. I will get with you again and your son and get that delivered. And that is all I have. I will introduce our speaker is Nicole Cannarozzi. She's from the archaeological wing of the Florida Museum of Natural History, and she's going to be speaking to us tonight on zoological analysis of shellfish from St. Catherine's shell ring, which I depotage, I guess, from folks eating from the archaic period. I won't try to go into much more than that. She is a PhD student at the University of Florida, and even though it is nice and sunny behind her, it is pouring and storming there. And there's a good chance if something happens with the power, we may lose her, but we're hoping it'll work out. And so, Nicole, take it over. Welcome.
Great, thank you. Thank you for having me. Let me go ahead and share. Okay. Just minimize this little window here. Okay, so good evening, everyone. Thanks for inviting me to share with you today, and I'm glad to be here virtually with you all. So yes, my background photo is actually of Dickinson Hall. So for those of you who may not have been to the museum, we have the exhibits side of the museum, which is the public side. And so you may recognize that, but Dickinson Hall is where all of the behind the scenes action happens. So that's where our lab is, the environmental archaeology lab, and that's where also all of the paleontology labs are as well. So I'm going to talk to you tonight first a little bit about what environmental archaeology is and about our program at the Florida Museum and the different kinds of research that our curator and the students in our lab are working on. And then I'm going to talk more about my research in detail on the Georgia coast. So what is environmental archaeology? It is the study of past human interactions. And what we do is reconstruct environments, and that includes plants, animals, and landscapes. And we're interested in how people interacted with their environment. So what impact people had on the world around them, and vice versa. So one thing to note is when we talk about the environment, that for us also includes the social environment, because what we're really interested in archaeology and anthropology is people. So people make decisions not only in response to the physical environment, but also in relation to social conditions. So things like ideology, perceived threats, or food scarcity, those types of factors can influence perception and responses to our environments. And so we can address questions like that. And that also includes not only negative, but positive impacts. And because we're looking at this long record of humans on the earth, the data that we can provide also has the potential to provide insights on some contemporary issues like climate change and biodiversity loss. So environmental archaeology lies at the intersection of anthropology and biology. So a lot of the methods that we use to address some of these questions, the methods and techniques are derived from fields like biology and ecology. So we use those methods as tools to kind of address some larger anthropological questions, like the ones I mentioned before about how people are using their environments, how they're living on the landscape. And that focus again is still on people, so we can actually address questions that speak to both biological and anthropological questions. Okay, so there are three subfields of environmental archaeology, and they're zooarchaeology, which I'm a zooarchaeologist, and that's the study of animal remains. That's both vertebrate and invertebrate animals from archaeological sites. There's also archaeobotany, so that's the plants, and so that includes macrobotanicals like wood, seeds, and nuts, but that also includes what we call microbotanicals, and that's pollen and phytoliths. And usually there's actually different folks that do those types of research. So you may have someone that does only macrobotanicals, but may not be well versed in analyzing microbotanicals, because that's sort of a different skill set. And then we have geoarchaeology, which is the study of soils and sediments, and it's for understanding how people used land and soils, the created soils in the past, or formed soils. So that just started to get you thinking about the bigger picture. So since I'm a zooarchaeologist, my research is focused on zooarchaeology. So I'll talk about that. But first, I'll talk a little bit about what some of the other projects are going on in the lab. And so I'll start with our curator. She is a Mayan archaeologist and is also an environmental archaeologist who actually uses all three of those subfields in her research. So many of her projects combine all of those to get at various types of questions. But one of the projects I'm going to highlight is her work on turkey domestication. So that's probably pretty relatable for all of us. And so she's looking at when the turkey was domesticated and adopted by the Maya, and looking at subsistence practices associated with turkeys and long distance trade and the connections through the Americas. And that's pretty interesting because turkey was one of the few animals that were domesticated in the Americas. So that has some implications for understanding domestication on a broader scale. And another project that she's been working on is called ZoArcNet. And what this is actually a database for integrating cultural heritage information with biodiversity networks. So we have all this data that has to do with our environment and animals and plants and everything that people were using, but we don't currently have a database, an open access database that other researchers and folks can use to kind of pull all of these things together, so we can kind of better understand everything that's going on in sort of a more holistic view. So nothing like that currently exists that includes archaeological data and modern and paleontological biodiversity data. And one other project that I didn't put up here actually is a grant that we have to actually recurate all of our archaeological materials. So the lab itself is actually unique among environmental archaeology or zooarchaeology labs because we have both archaeological collections that consist of sites that have been dug up over the years, and we curate them from sites in the southeastern U.S. to the Caribbean to central and northern South America. And so those are what we call legacy collections, and so they need to be really well curated. And so we're going to upgrade all of their housing for those collections so they can be better studied and better taken care of. So I'm going to highlight some of the students that are doing some research with just a quick little synopsis of each. So first is Randy. She is actually working on macaws in the greater Southwest, and she's looking at husbandry practices in the pre-Hispanic Southwest, where macaws were actually kept in aviaries. They were important in trade, and they had ceremonial significance. So their feathers were actually used and plucked to make various items, headdresses, and things like that. And she's actually working on some osteological analysis and CT scanning of some of their skeletal remains and looking for pathologies to reconstruct macaw husbandry and learn how these birds were cared for. So when you continually pluck, and I'm not sure how well you can see in this photo here, when you continually pluck feathers, it creates sort of this buildup of bone and some damage there. So she's looking at those factors. And then Lisa is working on residue analysis. So she uses chemical markers to look at food residues in pottery vessels. So looking at things like chocolate and tobacco. She's also a Mayanist, so she works in the Maya area as well. And these some of the vessels she works on are from Guatemala and Belize. So she's looking for things like chocolate and tobacco, even blood and meat, corn or chili peppers, and reconstructing recipes and looking at how some of these recipes may have been a defining factor for cultural differences among different communities. And then Ariane is working on what animals can tell us about the impact of Spanish colonial practices on the Maya. So she's looking at how the Maya changed or maintained the use and attitudes towards animals after Spanish contact. And so this is a modified shell that I think has been modified to look like a bird, and potentially this bird right here, which I cannot remember the name of this bird at the moment, but so this is an artifact that comes from the site that she's working on called Lamini. So she's looking at how colonialism actually has, what effect colonialism had on the use of animals for the Maya. And then similarly, Nicola is looking at the relationship between humans and animals during colonization as well. And he's focusing actually on domesticated species. And he's looking at how these introduced domesticated species like cows fit into established folk taxonomies. So how did they fit into a new landscape where they had never been before, and how that impacts the ecology of the animals and the management of those animals as well. And then finally, Petra is looking at cholos. And so that's the hairless Mexican dog, and looking at their breeding in ancient Mesoamerica and what they considered was the breed standard. So if any of these topics are of interest, there's other folks in our lab too that may be able to give some really interesting talks as well when you're looking for another archaeology focused talk in the future. So my research is on the archaeology of late archaic shell rings in the Southeast, and specifically on St. Catherine's Island, Georgia. So these sites, shell rings, are sites that date to the late archaic cultural period. So that's between 5,800 and 3,200 years ago BP. And there are over 50 of these sites found primarily on the coast of Georgia, Florida, South Carolina, and Mississippi. And they consist primarily of shell and mostly oyster, but they also include bone, botanicals, artifacts like lithics, ceramics, and then soil mixed together in the outer parts of the rings you see here in these mounded sections. And this is just a reconstruction of what a shell ring may have looked like when it was active. But they're unique in that they were deposited in these circular or arcuate shapes and what appear to be these central cleared out plazas. And as you can see in this next slide, that they're actually pretty diverse in shape. So we call them shell rings because it's just sort of a general name for this class of site. But you can see they're actually pretty diverse in their shape. So the ones in Florida here are generally kind of arc-shaped and not always complete circles. When some are, mostly in South Carolina, those are more fully circular shaped. And they also differ in height and diameter. So some are as tall as 1 meter and others taller at over 5 meters. And then the interior diameter range from 40 to 200 meters. And they can be single rings, they can be paired rings, or occur in triples even, like here in Sapelo. So even though we categorize them in shell rings, there's a bit of variability among them. And another thing to note is that some of these shell rings, even though they look like they might be arcs, sometimes they have actually either been mined or sometimes mined for historic fields. And so it may look like it's an arc, but at one time it was a full circle. And in some cases, part of them are actually may have been underwater because they were built so close to the coast. So there are three primary schools of thought actually regarding the construction of shell rings. So what were they used for? Why are they in these particular shapes rather than what we generally see as just mounded sites where those are generally thought of as just food refuse. So because these have this particular shape, they've sort of been thought to be somewhat special, and maybe these sites had a special significance. So one school of thought says that the shell rings were primarily daily habitation sites where people lived year round, and the food remains just represent the throwing out of everyday garbage. Others would interpret these sites as monumental architecture and are the result of communal feasting events. So in this case, there's an expectation that if the sites are ceremonial, that they would go along with ritual events and would occur on a seasonal basis or align with major events, like for instance, the winter solstice. And finally, others think that they likely represent both everyday living spaces and ceremonial grounds. So that's actually highly likely and makes a lot of sense because we do the same thing, right? We live in our houses daily, and we also have, ceremonies and rituals and holidays at our houses as well. So after over 20 years of archaeologists studying these sites, these issues remain sort of at the forefront of these studies. So there are a number of ways that archaeologists actually address these issues of how the sites were formed and used. So the primary questions from my research are, what are the patterns of site and resource use? And from there, what can those patterns tell us about how shell rings were formed? So I use archaeological faunas to get to these questions, specifically for two sites on St. Catherine's Island, through both identification and analysis of fauna in the sites, but also through a method called sclerochronology. And that's used to determine the season of capture of certain mollusks in the site. And I'll get into that after I introduce the site. So St. Catherine's is, this is kind of small, not sure if you can see, St. Catherine's is right here. It's one of the Georgia Barrier Islands, and it's about 50 miles south of Savannah. And there are actually two shell rings on the island that were occupied at the same time. I haven't completed analysis for the second shell ring yet, McQueen shell ring, but I've completed most of the analysis for the St. Catherine shell ring, so that's the one I'm going to talk about. And these rings are actually on opposite sides of the island. So St. Catherine shell ring is here, and McQueen is actually right here above this site that I'll talk about a little bit later. So this map just shows the 3 units that I took some samples. So this darker red part is the outer shell-heavy portion of the ring, and here's the central plaza. And this line here is actually a historic boundary ditch where during when the island, in the historic times when island was being used for farming and such, they just came through and just cut through the shell ring there. So I purposely took samples from the heavy shell portions of the ring. And so in addition to identifying and quantifying the invertebrates from the site, we wanted to know if we could see any spatial differences within in the fauna within the ring. So are there differences here, and here in the faunal composition of the ring? And so maybe if there were, we could see if there were some differences in the way that the ring was deposited in different parts of its sections there. So I took what are called column samples, and you can see here in this photo that it's the last level here is kind of pedestaled. And so these are just small samples that represent a portion of the unit that was excavated. And so because there's so much shell, and I'm taking samples that were actually water screened in 1/4, 1/8, and 1/16 inches, that ends up being a lot of material. So taking a sample, I could still take a representative sample of the ring, but not have to analyze the entire ring, because that would take a really long time. And so what you get is, and you can see in this photo, this is what it looks like after it's been excavated and then water screened. So it just looks like a mass of shell, and that's what it is. So some of it is broken up. But what you may not be able to make out here is that this is mostly oyster. So because this was the primary component of the shell ring, and what actually most shell rings are made mostly up of is in terms of the shellfish component, is oyster. I wanted to see if I could determine season of collection of oysters, and then figure out when during the year people might have been collecting and depositing oysters. And that would tell me during what seasons of the year that the primary ring building activities were occurring. Well, I'll make the note here that terrestrial land snails are actually outnumber most everything else, but because I took those smaller samples, those appear to be the most numerous, but they're actually considered sort of commensals in a way, because they're sort of ubiquitous in the environment. And also terrestrial land snails will also dig down and estivate. So some of these could be modern, but I don't actually have a way to figure that out for now. So we can ignore that and know that oysters are the most prevalent mollusk in the collection. And so this is where the sclerochronology comes back in. So the skeletal remains of most individuals contain some record of its life history. And so a good comparison is actually tree rings. So just like tree rings, shells have these pattern rings or growth lines, and those are associated with the temperature of the water that they grew in. So what we say is that they precipitate shell, or they grow shell in equilibrium with the water temperature. So in some cases, you can see the rings pretty clearly, or the bands pretty clearly, and they're patterned. So if you look at the clam here, you can see these alternating light and dark bands, and you can visually assess these bands and determine the season that it died. So like you can see these, what we actually call dark and translucent based on the type of light that we're looking at it in, but you can see these dark lines, excuse me, coupled with the opaque lines, and that's a year's worth of growth. And so the darker line represents growth during the summer and autumn seasons, and then the lighter band represents the winter and spring growth. And these patterns have actually been verified with stable isotope studies, which I'll talk about in a little bit. And so hard clams have probably been the most used species for seasonality, because in general, they have these nice clear growth lines that can be evaluated visually. But you can see here that oysters pose kind of a bit of a problem in that regard. So generally stable stable oxygen isotopes are used to determine their season of harvest. So you can see here these kind of white chalky islands that are kind of floating in the middle here. So this is an oyster that's been cut in half, and this is the umbo, or the section right here, or the hinge. Oops. The hinge. And so when you cut that open, you see these little white chalky islands, but they don't actually correlate to season or temperature. They're actually, I think, just cheap building material for the oysters to kind of fill in, because as you know, their oysters are their shells are really thin compared to something like a clam. So these aren't really helpful in telling us what season these animals grew in. So like I said, generally stable isotopes are used, but that can get expensive. So I used a couple different methods to kind of correlate the two and see how I could get to season of capture for these oysters. So the first thing I had to do for the isotope method was to verify that oysters do indeed record the temperature, accurately record water temperature in their shells. So I collected live oysters on St. Catherine's for 2 years, monthly for 2 years. And so I collected them from a site as close as possible to the archaeological site. So on St. Catherine's Island in the Cemetery Road Marsh site is where the oysters that I'm going to talk about later came from. I actually collected from a number of different sites on the island, some even closer to St. Catherine's shell ring. But these are some of the ones that I've analyzed so far are from this site. So after collection, I get them back to the lab, clean all the mud off of them, cut them in half. So just cut them, bisect them down in half. And this is actually a really good example because this is one of the straighter oysters. If you eat oysters, or you've seen oysters, you know they are they're kind of shaped based on their environment and based on how many other oysters are around them, since they all stick together in these clumps. So a lot of times you'll get a really curved oyster, like this one is actually pretty curved. So it'll be curved to one side or the other, and cutting them can be kind of difficult. So this is actually just a better example. So you cut it down the middle and then you expose this area, which is the hinge area. And this is where the samples are taken. So I use what's called a micromill, which is sort of like a drill and a microscope combined. And I couldn't find a photo to add on here. So these little spots you see here, if you can see that, are the sampling locations. And the drill just kind of comes down after I set it 1 millimeter apart for each sample. They come down and drills out a little bit of shell powder. And that's what's submitted for the stable isotope analysis. So I've got a graph here, and just to simply say, so this is oxygen on carbon, and I'm only going to talk about the oxygen. So this looks like it's plotted upside down. So I have the negative values for oxygen here and the positive values on the bottom, but I've done that because the negative values actually indicate warm temperatures and the positive values indicate cooler temperatures. So it just makes more sense to me to have warm temperatures on top and cooler on the bottom visually. So, but what's important about this, these are the modern oysters here on the left. And this one was collected in July and this one was collected in February. So what's important about this is that this final collection point actually matches the temperature at the time that I collected the oysters. So I took water temperature at the time I collected oysters and also compared them to a buoy that was collecting temperature close to the area as well. So these line up. So it looked like just from these two samples that oysters were accurately recording the water temperature that they were growing in and not being affected by any other factors like salinity or anything like that. So that, compared to the oysters from the archaeological site, same thing. I could compare the values here and back calculate what we call paleo temperature. So there's an equation that you use that you put each one of these values in, and it'll tell you what the temperature was for that value. So here, for this final temperature, for these final temperatures, I've placed this one in the summer-fall category, or excuse me, this one in the summer-fall category, and this one on the top right, in the winter spring category. I know they both may indicate that since they're on the top that it looks warm, but in comparing the two and also looking at the temperatures, that's where those sort of fall out. So we have winter spring collection and summer fall collection for 2 individual oysters. And so another method that I used that was actually that's actually sort of a method that combines well, you're able to average or use a mode, so you can actually look at a larger range of oysters. So these guys are called otostomes, and they're these little predatory gastropods that feed on the soft tissues of oysters. And so you can kind of see in this photo they hang out along the side, the edge of the shell. So what they do is they have this proboscis, or this little stylus that they use to siphon out liquids from oyster soft tissues. And so they're pretty prevalent in estuaries with oysters. And so I was able to use some of these guys also as a proxy. And so they're a good choice because they're common in oyster reefs, and they're also inadvertently collected by people when they're collecting oysters, because they are attached to the shells, and they're also attached to the mud that comes up with oysters. And because these are so teeny tiny, so max about 6 millimeters, they're only recovered from archaeological sites when using small screens, so 16th inch screens or less. And so I was also able to collect and measure modern otostomes. So when cleaning those oysters that I'd collected for the isotope study, I'd realized they were there in pretty substantial numbers. And so a previous archaeologist named Michael Russo had already developed a method for determining season of harvest using these gastropods. And so I went off of his methods and tried for this area. And so what we have here is, like I said, just the mode. So what we can look at here is these are the lengths of the otostomes for each month, so a modal length. And so you can see here they start out small in the summer when they spawn in April and May. And so they start out smallest in the summer and get progressively bigger throughout the year. And so what you can actually see here, like I said, spawning in the spring here, what you could actually see is two peaks here where you can see this younger cohort, or this younger group of individuals coming in, and then the older individuals, which are longer in length, kind of dying out. And then by June, early summer, all you have is these younger individuals. So that's how I knew that they only live for a year. I knew that then they would be good proxies, because anything that lives for only a year, you can tell what season it's being collected in. And so based on those modern measurements, I took that same data and just plotted. So these are the modern measurements for each of the seasons. So summer, fall, and I did a late fall here because that kind of falls out a little bit differently. Winter and spring, and then I plotted the archaeological samples onto that too. So I only did 2 of the 3 samples that I took. And so these darker lines are the archaeological samples. You can see they fall out primarily in the winter and spring size classes. So it looks like oysters were being collected primarily during the winter and spring, based on this data, and also from the stable isotope data. So back to the questions that I posed at the beginning. So what are the patterns of resource site use? So it looks like, based on this study and previous studies actually from hard clams from the site, shellfish are primarily cool weather resources and are not being harvested, at least significantly, during the summer months. So we did have that one oyster that showed a potential summer and autumn harvest. But again, those were only 2 oysters, which is not a very good sample size. And then what can these patterns tell us about ring formation? And so since oysters are the most abundant shellfish at the site, this indicates that ring building activities primarily occurred during the winter and spring. And we know that based on radiocarbon dates that these sites were occupied over a number of years, and in the case of St. Catherine's shell ring for centuries. So the samples I presented are actually time averaged because those samples that I took were from basically from the top or the latest to the earliest parts of the ring. And so that spring harvest pattern, that winter spring harvest pattern was a strategy that was maintained for over 100 years. So now the question is, what were the driving forces behind establishing and maintaining that pattern? And some of the reasons may be that oysters in the southeast spawn from May to October, and when they do that, when they reproduce from May through October. And when they do that, the texture of the meat changes. It gets watery and it's just not tasty. So until around late December, early January, they become meatier again. So it may be that people were avoiding oysters at this time because they didn't taste good and because they may have been aware of potential health risks in eating oysters from warmer waters where bacteria may be increased, but also maybe just shared our dislike for watery oysters. So when you think of that old adage of eating oysters in the months with R, that seems to hold true. It's also been suggested that people of St. Catherine's may have practiced a form of mariculture, so actively cultivating and maintaining oyster populations. And avoiding oysters during the summer may have served to maintain the viability of those oyster populations. So it would allow them to recover during the summer without that harvesting pressure, and would promote their sustainability, so they could have another big harvest in the winter and spring and beyond. And it also may be that oyster harvest may have ceased or decreased during the summer because people may be focusing their maybe focusing on other seasonal resources or food sources like plants or fishes that are more prevalent or preferred at those different times of year. So I'll be looking at this question as I finish up my research, my dissertation research, and I'll be integrating this data with vertebrate faunal analyses and other data sets to kind of better understand how these shell rings were used over time. And that's it.
All right, so we have a couple of questions in the chat. Would it be important to know if the rings were destroyed by a specific weather event, such as a hurricane, compared to gradual tidal fluctuations?
I'm sorry, could you repeat that?
Sure. Would it be important to know if the rings were destroyed by a specific weather event, such as a hurricane, compared to gradual tidal fluctuations?
Yeah, and we haven't actually had any evidence of that so far. There are actually sites like in South Florida, they're not shell ring sites that do have evidence of hurricanes, but so far in the sites that I've looked at and the sites that other folks have reported on, there hasn't been any evidence of hurricanes specifically recorded within the sites. But that's a great question. That's something to look at.
Okay. Another question from the same person, Madeline. Would destruction by a sudden storm change your understanding of the people and how they lived?
Yeah, I don't know that it would change our understanding. I think it would definitely let us know how those situations are handled, right? Because we see that now, in contemporary times, how people handle storms and what happens. but we can also look at that in the past. Like on St. Catherine's in later times, there's actually evidence of drought, and we can sort of see a dispersal of people and getting resources from other places and actually potentially traveling to other islands as well, which they likely do anyway. Um, so yeah, looking at those storm effects are really important. And if we can find those types of evidence in the archaeological record, which sometimes in some sites just looks like churned up shell or churned up mounding material, it would be interesting to see after that what sorts of things they did to sort of mitigate those effects.
All right. And then another question is, could you apply these historic practices to modern day, avoiding oysters and similar animals during specific times to help grow the populations naturally?
Yeah, and yes, I think so. And what we do with oysters now is, since they are, they're genetically altered and they're I think it's called triploidy, so you can actually eat them, year round when you're you're getting oysters from a restaurant or something. But yeah, one of the things is to look at to study these systems in detail and look at how they best thrive, and then you can figure out what the best ways are to sort of maintain these populations.
And then Sylvia asks, are there more of one type of shell?
You mean, well, yeah, actually, so as far as the oysters, like a left and a right valve, or just within the shell ring?
I'll give her a second to clarify.
So I can say, in as far as the total composition of the shell ring, yes, there's oysters and there's quahog clams, what we know as like little necks, except they're like really big shells. And we have rib mussels, because all of those occur actually in the estuary together. So when I would go out and collect oysters, I would also see clams and mussels along too. And there's also whelks in the sample. There's also something called a stout tagalus that occurs in the shell rings. And right now, actually, so I'm in the process of analyzing that second shell ring. And actually, right now, it looks like there's more of that stout tagalus in that shell ring than oyster. So in St. Catherine's, it's mostly oyster. In McQueen, it looks like it's mostly the stout tagalus, which is this long little, I don't know if you know what a razor clam looks like, but it looks very similar to that. So it'll be interesting when that's completed to see what the differences are between those two shell rings.
Okay, I think that did answer the question. She clarifies, are there more of the same type of shell in a particular part of the ring?
Oh, actually, no. So at least from the samples that I took. So if you saw that photo, um, there's only, I only took samples from 3 portions of the ring. So at least from those portions, there does not look like to be that there is more of any one type of shellfish from each of those. It's always all oyster or mostly oyster.
Well, I actually have a question if I could. Am I on?
Yep.
Yeah.
So on your slide where it showed when you were in the bar graph, we were measuring the types of shell you were finding edible. Well, I mean, most people would agree that the oysters and the blue crab are probably the most desired, or the best tasting of all the clams and snails you mentioned. But the crab wasn't really measurable. And I mean, blue crab is, from living here in Florida, collecting blue crab, it's available all year long. I mean, it doesn't go bad like oysters. So why would you think the blue crab count would be so low on those bar charts?
That's a great question. So I think what's happening is that the samples may be biased because of preservation. So although crab remains do preserve pretty well, the only thing that we normally get are the dactyls or the claws. And so the difficult thing about that, so the way that graph was set up, I used minimum numbers of individuals, which is the way we calculate how many individuals of a species is in a site. So those actually get biased in crabs because the claws are difficult to side. So they'll have one large claw and one small claw, and that varies from left to right. So it's actually kind of difficult to determine how many individuals you have when you only have claws. Or what we get most of the time are just the little bumps on the claws. So they're likely just underrepresented in the analysis. Another factor that has to do with that is also the ribbed mussel, which is also in abundance in estuaries and is actually most of the time attached to oysters. Those are really fragile. So when you saw that photo too that was with the graph, all of that crushed up looking stuff was mussel. So there really is a lot of mussel shell that doesn't get quantified because you can't cite it and you can't tell what other shell it came from. So there's really no way to count that other than just pieces of mussel. So that's a great question, and it speaks to sampling bias and preservation bias in the site.
Okay. I have one from Sam Milligan, who's actually sitting next to me, but he texted in there. Knowing the seasonality of the oyster harvest, does this provide any evidence of the ceremonial versus domestic theory of the ring use?
That's also a great question. It really doesn't unless unless you can find other evidence that there is actually some sort of ceremonial activity going on. So really all that tells us is that, okay, something was going on during this time of year where they were eating a lot of oysters and depositing them at the same time. So we'd like to interpret, and usually, just like in paleontology, when you guess, you interpret what an animal looks like based on, what its bones look like. We're doing the same thing in archaeological sites with this evidence. It's like we're interpreting and building a narrative based on what we find. So if we found some other evidence, like maybe I don't know, like a carved shell or something like placed in a certain way, then we could say, okay, maybe this was an event and this was a ceremonial event. But what we can really say with the seasonality information is like, okay, it looks like they were doing something consistently during this season of the year.
All right, Nicole, that looks like it's our last question, unless something pops up. People are saying thank you on there as well.
Thank you.
Rozzy, I appreciate you coming out tonight to meet with us. I'm glad the thunderstorms there didn't cut you off.
Yeah, me too.
You're welcome to hang around and watch us goof around for another few minutes, or you can bye, but it's up to you. We do have just a couple more minutes to go here, some prizes to give away, and that's about it. So thank you very much for your presentation, and good luck with your PhD studies. And we will hopefully see you again with another presentation.
Thank you so much. I appreciate the invite.
Thank you. And tell your other fellow archaeological people that the fossil clubs love them too.
I will do.
Thank you very much.
Right. Have a good night.
Thank you. So we're going to give out, I'm going to give my phone number out one time and only once, because Eileen has to explain that later. Eileen has to scrub it off because she doesn't want my phone number on there forever, and I appreciate that. So if y'all are ready, I'm going to give my phone number out one time. It's area code. And I'm going to give out the kids pack, or an adult kid, but there's toys in here, so I don't judge. And second, we're going to give out the manatee teeth, the one with a kind of rare with a full root on it. You don't find those too often. These are all fossilized, so I don't need the John Cronin, you're jumping the gun. I don't need the Florida Wildlife coming after me. These are all fossilized. And I'm going to take the fifth caller for the kids pack. John Cronin, you don't win. Y'all can call now. John Cronin is the second caller. There's a little bit of delay, so I'm sitting here staring at my phone. Leslie Brandon is the third caller. They came in faster last month. Although we have about 35 people logged in right now. That probably equates to about normal, about 70 people. I know most people have 2 folks at the place. We have 4 here. I know several other households that got 4 looking. Rain Vierbeck, he's our 5th caller. Hey, Rain. I am doing well, and with so many calls coming in, it is hard for me to hung up on Rain. But Rain wins the toy pack. Don't know if he has any grandkids yet, or neighbor kids, or nieces and nephews, but that's his. And Denise Newman. Denise Newman.
My Searle.
Denise Newman, she hung up. Oh, you're here? Denise, you won the manatee teeth.
I won the manatee teeth?
You did.
Woohoo!
You will have to submit a tax winnings of, these are worth about $5,000. So make sure you include that.
You're kidding me.
I'm not freaking kidding you. Watch your language. You are live. But you are the winner. And Denise was our editor for many, many years. We appreciate the work you've done in the past. And y'all can stop calling. Denise has won our second prize. I will get that to Denise and get the toys to Rain. Denise, I'm going to hang up on you. Thanks for playing.
Love you, Mike.
Love you too, baby. And I will if anybody has any questions for me, it's been a while since we haven't been live. We missed you folks. If anybody has any questions for me about the club, they want to scroll across, you can type those in now, and I'll see if I can answer your questions, as long as you don't make them tricky. If I don't know the answers, I'll ask my wife. She's in the kitchen. If I don't see any questions come across, I'll say in the meantime, we have no meeting in March because we're going to do the swap meet on the first Saturday in March, March 6th. I hope you folks will come out and see us. We've missed you guys a lot. I'm sure we'll have the vendors sold out at least 30 vendors, and it's going to run 9 to 3. Easy. It's centrally located. Please come out and see us. We'd love to see you guys. I don't see any questions coming across, which means I'm not going to get stuck on this. Oh, well, nope, no virtual meeting in March. Swap meet instead. And I think that's it. Nobody's typing nothing in. If you're too busy to go fossil hunting, you're just too busy. Love you guys. See you next month.